So thank you for joining us for our next talk. The next talk will be about Collabora Online, WebAssembly, and it's going to be with Caolán and Thorsten.
Okay, I hope you can hear me. I can hear myself. So Collabora Online, WASM, myself, Caolán McNamara and Thorsten Behrens, and we'll just get on with it. Collabora Online, typical overview. What we have is I can shout louder, but again, it's meant to be amplified. Collabora Online, typical overview. The idea here is that you have Collabora, you have your browser, you have a JavaScript front end. The JavaScript front end communicates back to a server. The back end server is a classic C++ compiled to native code. There's a web server daemon that basically manages a whole set of Kit instances. And obviously, crucially, with all these things, if there's no server, then it doesn't work, because the browser talks to the server. If you have no server, if you lose connectivity or connection to the server, then your browser has nothing to communicate with, and nothing works at all. Each Kit instance that I mentioned there is basically LibreOffice. It links to LibreOffice core. It's big. The combined shared libraries on my local copy of it is 320 megs. So you've got a very, very large core body of code from LibreOffice that is included and linked to by each Kit instance. Each instance is one document, so when you connect to Collabora Online, each document is running separately, and each individual document is its own instance. When you've got multiple users, it's still one document. If they connect to one document, if you've got one user, 3 documents, you've got 3 instances. And then the server mediates between your browser and forwards things to each client. Client renders images, and you send back these pictures back to your JavaScript client. LibreOffice itself, core part of it is pretty portable. We've ported it to all these operating systems here: Linux, Windows, Mac, iOS, etc. On the core side, we have the famous bridge, which is particularly specific to the ABI of your architecture. But we have ported it to all these architectures and all these different ABIs in the past. So there's plenty of experience and plenty of examples of being ported to very, very, very diverse sets of things at a particularly low level. Collabora Online itself then is pretty much doesn't have the issue of requiring this low-level bridge, so its portability is fundamentally easier on that side, even though then it is going to use Linux basically based APIs. So again, 2 things that are relatively portable in their own sense. Which brings WebAssembly in.
Yeah, that's my cue, I guess. Who in this room has not heard about WebAssembly? Okay, so great. So this slide is for you. Yeah, in all brevity. So WebAssembly, well, the idea behind WebAssembly just is to have something that runs in the same sandbox as Java, but is much closer to the actual machine level abstraction that languages like C and C++ are having, which the vast, like this massive amount of software out there already in those languages to be able, which is a smart move to run this in the browser. The history of that is the WASM.js, like it started 2011, 2012 or something with WASM.js, also this Google PNACL project, where that started with a subset of the JavaScript, so that is able then to be run relatively performant, like almost like native performance in a browser. Fast forward a few years, 2015, WebAssembly became a standard, started implementation in a browser, like with the W3C. The mScript project, big kudos, by the way, to mScript for enabling that, based on LLVM framework to compile C and increasingly also C++ and the more complex features there down to WebAssembly. Yeah, so small asterisk, some footnote there, some website security policy is still required to run that because of the way of actually running in the same sandbox. It's using the shared array for actually having the memory and also the code there. If you look at the roadmap and the browser support, then you realize this thing has arrived. It's pretty ubiquitous. Not all the features are there. Some features are beta or just in the process of being standardized. But regardless of where you are, mobile or desktop or anywhere, like even this Node.js and WASI, like on a server, has excellent WebAssembly support right now. There's the roadmap there. And with any decent browser, you have at least a subset of that, which is good enough. Which gets me to what does it have to do with LibreOffice here? So in 2015, we had a first look at that because it's kind of obvious to say, well, LibreOffice is so portable, why not port it natively to the browser? And we utterly failed back in the day. It was just the way that the C++ support that was available in Emscripten was just not enough. I mean, there was essentially no decent support for exceptions. There was a lot of problems with the with threading. So we tried again in 2021, and we're very grateful to, in particular, NLNet, but also to Collabora and my company for funding that. And we started again, and long story short, we succeeded to port that. It was quite a ride. It took more than a year. But yeah, given the fact that LibreOffice was already very portable, the build system was already there, Emscripten was already there, a lot of the building blocks were there. Qt, which we use for the GUI thing that you see there in the screenshot, had already been ported, so lots of those bits and pieces were falling into place. Some of them actually, while we did the port, so we were actually still quite lucky that in the end we were successful. So yeah, and why did we evaluate that after this initial failure? Because things like AutoCAD and Unreal Engine and all those projects had already ported, so we were reasonably confident that we were still hitting those nasty roadblocks. LibreOffice has this habit of breaking everything because it's so large, and so did we. So, for example, at some stage we wanted to link, and it took almost 100 gigabytes, and took 2 hours just to link the thing, which kind of sucked. And then a few months later, Emscripten upstream fixed that, and we were happy again. So, yeah, that's the story of that port. And with that, I guess, back to Caolán.
Indeed. So yes, so now you have LibreOffice WASM port. So what do we do then for Collabora Online offline? So Collabora Online WASM, so co-WASM. So we took all that. What we do now in that case is in the previous diagram you have your server running on the distant, far away server, physical server. And now in this case we bring the Collabora Online server side and we run it inside the browser. So you've got exactly the same JavaScript front end. The JavaScript front end communicates to the server, but the server is actually the original stuff converted by Emscripten to WebAssembly and running inside the browser. So your server is inside the browser. You have the same architecture, but you're only running one document in this particular case, all inside the browser. So again, the core stuff that Thorsten mentioned, and then also port and sort out online to WASM as well. When you're sitting in front of your browser and you click this particular offline button, as it is currently at the moment, you manually ask to be put into the mode. You redirect it to a page that gives you the WASM, that downloads the WASM for you. And if you get that just right, you can get the WASM into size, to a particular size and location that it's a one-time download. So the next time you go into it, it's a particularly quick process. You give it a copy of the document, and then it executes inside in your browser, and your JavaScript client communicates to the server like it normally does. Thorsten mentioned it and kind of mentioned there is a security policy, but I think that becomes really, really problematic because you don't tend to just run Collabora Online. You run Collabora Online, and then of course it's launched from Nextcloud, and it integrates back to get its documents from that or any of the other examples. So there's an intricate dance of multiple web applications and multiple web servers, and then because of this particular Spectre flaw, the browsers are incredibly paranoid about letting you run WASM, and it's real difficult to get it to allow you to run WASM and to get multiple places working together. So all the links will give some of the documentation on that. But what it seems to boil down to is that the thing that you're embedding into and the thing being embedded both have to agree that they're happy with being mixed together, so that one isn't being tricked into being embedded in the other, and the other one isn't being tricked to embedding something it had no intention of running in the same browser as it. So thanks to Nextcloud, thanks to Julius Hartl there in particular for helping us get it bootstrapped up so we can get Nextcloud's which document to provide the appropriate security headers to at least get the first step started. And there's a particular pull request there that took us ages to get sorted out. You have to get your initial instigating website to give you the headers. Then on your side, on the Collabora Online side, you have to get matching headers to say that you're happy with being put inside of that. Then you have to get, it only really will work if you have Collabora Online in the reverse proxy mode, so that it all appears from the same server from the browser perspective. That works for Firefox just like that, but for Chrome it has to be SSL. It won't let you do it if you don't have HTTPS. We found out when we experimentally deployed it that a lot of our own websites pull our logos from a third website, and again, if that third website isn't happy to be included within this process, then the logos are broken. So in the end, then you come up with basically that if you have WASM enabled, we set up some capabilities saying WASM is in line, and then we put all this cascade of headers all becomes conditional on wanting to support. There's a lot of practicalities as well. I mean, when it actually runs in your browser, things are pretty good, all pretty slick, I believe. But actually building it, Thorsten talks about the 100 gigs now. If it's improved now, you only need 25 gigs of memory to link it. So that's pretty challenging when you're unaware of what's going wrong there. It's cross-compiling. Cross-compiling is always a little bit fraught. In my particular case, I've used the toolchain that Alapropria had. Putting together your own toolchain is painful, so you have to invest time in that. The threading is a little bit unclear to me what's going on there. We're using Emscription, and then we have the standard C++ APIs for talking about threading, and if on my particular machine I inquire how many threads I have, it'll tell me 20, which is the actual number of hardware threads I have. But then when you actually go and run things with threads inside the WASM, you find that it seems to have a practical limit of 4, so you've got a mismatch there between what two APIs are telling you, one of which is telling you 20 threads, and another one is limiting it to 4.
And it's lying, it's 4, so that's hard compiled.
Yeah.
And
so you run into problems there. You have to watch out for it. You have to just limit things down to your 4 threads and dismiss or ignore what some of the other APIs are saying. This particular one is incomplete. You manually decide that you want to go into offline mode, and it works beautifully, but that's not particularly useful perhaps in the real world because you can't go back online. So once your document is inside the browser, it's inside the browser, and it's not going to be migrated back to online when your connectivity restores. But it does work. I'll just show a little video, even though I actually do have it working locally, but you'll have to trust me on that one. So this is your online as usual, just to distinguish between the two of them. Just knock the network down, and then I just hit Firefox's offline as well, just to get quickly to the server's been disconnected. Type. No effort. Obviously nothing's going to work because you're not connected to anything. Back online, we go back to reload this, I believe, and we should flip over to the view file and go offline is the magic button. Click. WAPI downloads, starts instantiating, comes back up with a copy of the document. We drop our connectivity again, go back, speed up the process here, and we should be able to interact with the document as it runs inside the browser to its jailed or whatever its slave copy of Collabora Online executing in WAPI. It looks exactly the same, even because it's non-trivial that it looks exactly the same, but it does. It's interactive. You can move around with it, and it works fine. Can't save back. The about says WASM. That's nothing. Doesn't prove anything, but that is the case. I think I have just got one last slide just to say that is the end of. Anyway, okay, thank you. I'm not sure. Yeah, I think we're doing good on time, so any questions or anything? Otherwise, I think I could.
So I didn't fully understand. Does it save the document somehow inside the browser, but you cannot get it out from there, or can you save it somehow there inside it?
Once it's in the browser, if you could manually use save as or download as. It's not. You can do that, but what you can't do is just click another button that says go on. Right now you can't do it. It's not like there's some fundamental problem. It's just not done yet.
Save as and
you
for instance continue editing with your local copy of
Yes.
LibreOffice on the laptop and then upload it again online or something like
Yes,
this. But
you could.
yeah.
You could, yeah.
Thanks for the talk. I can imagine that the idea on switching from online to offline is that you will be able to switch freely between online and offline. What is there the idea or the plan or the challenges you might find to switch easily back to online? For instance, when your internet drops out and it comes back, that it automatically...
Well, it's just a matter, I suppose, of some of the practicalities of I don't think there's anything fundamental. I think it's just probably a matter of time to be let investigate the problem a bit further. But if you've taken it offline, you're just going to have a little practicality when you come back online. If somebody else has opened up the document in the meantime, you just come back to the classic problems of just file locking it. You know, do you go offline? Do you just? I mean, that's what I would do. I just say, you know, it's locked. You know, can't write back to it till it comes back online. Whatever. But just file locking. But there's nothing new or unusual about that. This is the live version of the WASM 1 in case anybody wants to, I don't know, look under the hood and make sure I'm not online.
So I have another question. Let's say there are 3 people working on the document online, and then one is dropping off, continues to add comments. And what is your strategy of catching up with the changes that have been carried out online in the meanwhile?
It's the same issue again. Like, yeah, what are we going to do about that? I mean, to be decided, I guess, is the answer there. But I don't think there's anything fundamental with that. I mean, it's the same as if you were back in the case where you have your shared network and you have a shared document and you had your classic clients and they open it up and it's locked by another user or whatever. You just have to decide what strategy you want to employ there. So, yeah, an open question, really.
Yeah. So first, amazing work. It's really incredible to see this working. I have a question about memory consumption. Have you measured more in detail the memory consumptions, and are there strategies potentially to minimize that memory consumption, to like reduce it as much as possible?
Yeah.
The second question is there a possibility for having multiple documents open in the same WASM module?
Yeah. On the first one was memory consumption. We're focused initially on just the size of it, getting the size down, the physical size down of the binary, which I guess we've done. We're happy with that. Memory consumption of it itself, I haven't really looked massively at it. I mean, it's the same as memory consumption for any of them. I think this particular computer has, I think it just has the 4 or 6 gigs of memory, and there's no particular problems with that. If you have one document, if you start, if you want WASM to run at the same time, you do an 8-threaded build of LibreOffice, then yes, you run out of memory on this machine. So it's like one or the other. So no, I haven't done anything particular about that. We did have issues, as I said, with the threading, and some of the threading, of course, was causing excessive memory usage. So happy with that.
So
the other one was second question.
So in terms of memory consumption, the size, let's say, footprint of the binary, like when it's compiled, like compared to what you get into some very heavily JavaScripted, lots of advertising websites, it's not fundamentally different. Let's not orders of magnitude larger or anything like that. So while it's relatively large, it's not like in this day and age for at least desktop browsers. As Caolán said, it didn't trigger anything. But I did not measure like specifically the. So for the let's say a document itself is not very heavy, but of course you need to load the you need to load the binary into the sandbox. There is clearly a problem, or there would be a problem if you run 5 or 6 or 7 or 8 documents. There's very little sharing, but there's a cache possibly that shares, but the actual footprint in the browser tab, that's not shared, from what I can tell. So valid point.
Just 5 minutes. I think the other question was
2 documents. Yes.
two multiple documents, and I think did Thorsten cover that, did he? Did you answer the second question whether you have multiple documents?
I covered that.
Okay. Yeah.
My question was in relation to the last response. Could we have a cache strategy or something to cache the code? That's what I'm thinking, to speed up the loading, first loading especially, or multiple tabs. My idea was a browser extension or something where we could put the WASM in there and then load it as you need it. But I'm not sure if browser extensions allow such use cases.
I think we're happy with the caching as it is. I mean, yeah, no, I think the download and the caching seems to be sorted now, right? The load time isn't fabulous yet, but that's just the nature of the beast. I think we might be short on time now.
We have one question also.
Yeah, just to be clear, a document is a file on the server, and then it's pulled to the client. So you might as well access it over another file sharing mechanism as well, like SMB or NFS.
When you're in your classic online Collabora Online case, the document tends to be in some other kind of a WAPI server, and you get it from there, and online can get it, and then it presents it as a file, just as a simple file for the browser case. So in this WASM case, the WASM doesn't do any direct connection back to the original WAPI server, so it's the online is allowed to get the document.
On the server side, is it also stored as a file, or does it end up somewhere in the database?
As far as even Collabora Online is concerned, it just is asked to fetch the document and is given the bytes for that document. It doesn't really know where those bytes come from in that kind of a sense. So, neither of the two really have access to the underlying location where the files are. That's why I look at it, at least.
Just coming back.
Thank you.
This one is GitHub, and Nextcloud is pull and so on with the link.
Yeah. Where did I put that?
Can you repeat the question?
He just wants to see the.
There is a long number with 32 or 33.
Yeah, I'm not entirely sure where that's gone now. But the slides will be uploaded to the place for that. Must be somewhere here. No? Back, is that this one? Or the next one?
No, for the next one.
This one, 320, yeah.
And then
3260. Yeah. That, yeah. Yeah, that's just where the propagating the headers that need to be passed around the place to get it up and running.
Okay. Thank you.